let's talk a little bit about loops. Actually, let's not, because you're not seeing my screen. Wow. Okay. Now we can talk about loops. We lock the door so we don't hear the cleaning people. We have seen now two of the main, or actually three of the main ways of combining programs or pieces of programs, right? We have sequencing, which means you do this, then you do that, then you do that, right? So we have been writing programs and functions that have several steps, right? They're done in sequence. So whichever one you put after gets done second, right? So sequencing is a control structure. We have also seen conditional, right? You do either this or that. And with recursion, conditionals allow you to do everything, right? We're using recursion mainly to do iteration, right? To go through all the numbers. When we are counting and printing, we go through all the numbers between from and to, right? And when you're doing print fifth bus, you go through all the numbers between from and to, and then you print the fifth bus of that, right? And when you do is prime, you go through all the numbers, right? Between 2 and n minus 1, and then check whether it divides or not, right? We're doing a bunch of those things. Now we are going to do it explicitly with looping constructors. Looping allows us to explicitly do that stuff, do iteration. So there is three kinds of loops: do while, and for. And I'll cover the do while first, but I never use it. It's just one of those things. Most people don't use this, but it's there. The do while loop has the syntax: you say the keyword do, then you have a body, whatever you want to be done, right? Normally you put the braces because you want to do more than one line, more than one statement, more than one thing. While, and then a condition. The parentheses are part of the syntax, just like with the if. And so it will keep doing that stuff, whatever you put in the middle, while that condition keeps being true, right? What does that tell you? What happens if the stuff in the middle never changes the condition? It will keep going forever, right? So somewhere in the middle, you need to change the condition, right? Or change some of the things that are used to calculate the condition, right? And that will be general for all of our loops. Just for fun, let me do this. Did I create something here? Touch loops.java in class. I just realized that I destroyed all of my IDEs. I messed up my Mac. I installed Java 9, and so they're not really supposed to work with Java 9, but they don't see Java 8 anymore, so all of my IDEs are messed up. Which is not a big deal. I can use a text editor. It's just nicer with an IDE, but I'm not gonna. So import. Let's do this. Class loops, because I named thing, and then I'm gonna do int main. Actually, it's not int main, it has to be public static void main, right? And I'm gonna have main, and here I can cut and paste my thingy. And then we can go see what does this do, right? It's a function called what? read and sum, and it takes a scanner, and it returns what? An int, right? It's gonna read numbers, right? And it's gonna keep adding the numbers it reads until it reads a 0. When you tell it 0, it will stop reading, and then it will return the sum of those numbers. Does that make sense? So, I have a variable to store the sum. I have a variable to store the input. And so I have a do while loop. Do print, please enter a number, 0 to stop. Probably should have passed, shall we do it? A print stream, right? We should never do horrible things. So now we can do auto print line. We never do horrible things. We only modify the things that we're given. We read an int from here. We add it to the sum, right? And we keep doing that while the input that we read is different than 0. When the user enters 0 in here, what will happen? We actually add that 0 to the sum, which doesn't terribly matter because it's 0. And then we get out of the loop and go to this line, and so we return the sum. Does that make sense?
Yeah.
Cool.
Does it do the do stuff first before evaluating the while?
Sorry?
It does the do stuff first.
Yes. The do while loop, right, is should first, ask questions later. So first, you do the body of the loop. You do this stuff. And then you ask whether you should have done it. May not be the smartest thing in the world, but in this case, it makes sense because I always have to ask. Does that idea make sense? So it's not necessarily wrong. Let's see if this would work. I'm gonna call read and sum of system.out and the scanner. And I'm gonna pray that this actually compiles. It's not gonna, don't worry, it's normal. We have been cheating and using either an IDE or Gradle to do our compiling. The most basic compiling is Javac, the Java compiler, that will only compile one thing. But it still works. And of course, it doesn't work. It doesn't know about print stream and doesn't know about scanner. What do we need to do? Not define them. Doesn't know about the class print stream and about the class scanner. Why it doesn't? Why doesn't it?
Use namespace?
Yes, but in Java. I need to import those classes because I'm not using the full name, right? But of course, I need to remember the name of those classes, which I never do because it's at the top of all my programs.
Yeah.
But let's Bing it, not Google it, please. No, sorry. Java util scanner. So import Java util scanner, and then print stream, which is Java IO print stream. Now with some luck, that will work. Yay! And how do we run our things? Java without the without the C. Please enter a number 3450. Woohoo! Maybe at least it stopped. What did we forget to do? We didn't print it or do anything with it, right? I'm going to start cheating. 3, 4, 45, 5, 0. The sound was 53. Woohoo! Does this make sense? Any questions on this? No. No. Okay, cool. That is the do while loop. We have a couple of other loops. We have the while loop, which is almost the same, except you put the while at the beginning, and so you don't need the do keyword, right? And the cool thing about this one is that it actually asks first. Right? For something like read and add, read and sum, it doesn't terribly help, right? Because what happens if I do this? Oh, I can actually cheat.
Minus 7 equal.
Oops. Not minus 0. Would this work?
Depends on what input is initialized to.
What is input initialized to?
John?
There are different ways. One is try to remember which programming language you're in and what it does. I think Java initializes to 0 for primitives, but what's the safe way to do it?
7.
Put something there. What should we put there? Would this work?
No.
No, why not?
Because the condition says that it's not going to run unless the input is not 0.
Exactly. It's only going to run while the input is not 0, so if the input is 0, it's not going to run at all. Does that make sense? The do while always runs, always, right? This one you ask before doing it. But as long as we do something that doesn't have that 0 in there, it will work. It is slightly uglier, but it works. Does that make sense? Slightly more awkward, but it works. Right? You guys understand how the while works? And actually come and look at this one because that helps us with the other one. Power, which we use 700 classes, right? It's like almost every class has a power function. How can we do it with a while loop, right? Power equals 1 while exponent is greater than 0. Multiply power times the base and decrease exponent. Eventually, you decrease the exponent times, and so power got multiplied by the base exponent times, which is what you want. Right? Isn't this cool? Sometimes, right? Is it easier to do it this way or with recursion?
Depends on what the thing is, I guess.
How about power? Raise your hand if you think recursion is easier. Raise your hand if you think this is easier. So most people think this is easier, 1 or 2 recursion and a bunch of, so about half this, about half loops, about half don't care, or were too lazy to raise their hand, and 1 or 2 recursion, right? I think the real answer is what he said, and I can't remember his name. Daniel. What Daniel said. A lot of times, it depends, right? It's perfectly okay for you to do it that way. A lot of times, people who have programmed before like loops. Why? Because they were taught loops, right? And they have been using loops forever. So recursion is weird and unusual. If you have not programmed before, you have an advantage. They're both weird and unusual. And so it is perfectly okay. Make sure that you learn recursion. If you have programmed before, also make sure that you learn recursion. It's very useful for more complicated problems. We'll probably only see one. If you're doing data structures, recursion is your friend. Recursion solves 80% of this stuff in data structures in 5 seconds. It's a lot easier and nicer than loops with pointers. So you can do it with loops with pointers, right? In fact, that's what the teacher probably teaches you, but if you can use recursion, it makes your life so much easier. But when you get to trees, you have to use recursion. But, could we do this with a do-while? What would be the problem? If we get something raised to the 0th power, right, we might end up going one more or something like that, right? So we need to do ugly stuff, like maybe putting an if inside the while, the do while, or just at the end just dividing by base just to do one less or some horrible thing like that. So sometimes one loop is better than the other. Actually skip to the good loop. For the most part, if you look at this, right, we have kind of 3 separate things, and many times in our loops we have these 3 separate things. We have the kind of setup. We set up stuff for the loop, right? We have the body of the loop. Well, we have the condition, we have the body of the loop, and then we have this stuff where we change the condition variables, right? The increment part. Or in this case, it's decrement rather than increment. Does that make sense? Most of your loops will have those things, right? Here, I have my setup, I have my loop, and then I have, this is actually part of the loop and the condition. So this one is not clean. But in many cases, I have those 3 things. So the for loop is just prettier syntax for a while loop. It is exactly the same as a while loop, just with prettier syntax. So what I'm going to do is I'm going to write for instead of while, and then I have 3 things separated with a semicolon. I have my setup, I have my condition, and then I have my increment or decrement part. The semicolons in the syntax look a little bit weird, but they make these pieces clear. They make a lot clearer what's my initialization, what's my condition, and what's my increment. They also make it unlikely that I will forget to put this line and get into an infinite loop. Does that make sense? It's just syntactic sugar. All three forms are equivalent. You can live with just learning one. In fact, in this course at least, I will not require you to do any one of those. You can pick and choose. The most common choices are either pick a while loop and just stick with it, or pick a for loop, because it's kind of the nicer version of the while loop. Sometimes you end up with ugly stuff. But you should be able to read all three of them, right? But not necessarily. I will not require you to write stuff with a particular loop. Maybe in the, I think in the assignments I do, but not in tests. Maybe. Now you know all there is to know about loops. Not all there is to know, but almost all there is to know. Let's do another example. That was there, right? With the while loop contains digit plus a number contain a digit, right? We did this one with recursion, right? And it was actually pretty with recursion, but while the number is not 0, last digit equals number %10, number modulo 10. If the last digit equals the digit, then return true. If not, make number equal to number divided by 10, right? And that eliminates the last digit. And we keep doing that. It's that cool. Let's try it just for fun. Yeah, we'll see. Oops. No. Oh, I never declared POW. Oh, because it leaves inside the loop only. So we need to do this. F is good. What? Oh, we are still doing this. So let's compile it. And it prints true, because 3 is a digit of 1, 2, 3, 4, 5, right? Could we do this with a for loop? Actually, we can very simply do it with a for loop. And this actually works. Just put semicolons around it, right? And it works. What do I do at the beginning? Absolutely nothing. And what do I do to increment? Absolutely nothing. And it works. Probably want to do one where I print false, just to verify that we are not. Oops. What would make it nicer, right? Which piece do I have here? I have this one, right? Where would this go? Before the first semicolon or after the second semicolon? Before, then it will be done only once before the loop. After, right? So we want to do it every time after the body of the loop. Does that make sense? This will actually work. If I want to, I could even do. Oh no, because this will only get done once. I need to do this inside the loop. So I cannot just move that to the initial fetching, right? The initial fetching gets just done once before the loop. The condition gets tested before every iteration, and the increment part gets done after each iteration. Gets done after the iteration and before checking the condition. Is this cool or what? What other examples can we do of loops?
Could you do something with negative numbers?
What with negative numbers? Something with negative numbers. What would negative numbers do? Read and sum until you get a negative number, or read and sum until you get a positive number, or something like that. Or what? Should we do? What do we do with negative numbers? With for loops? Or with loops with negative numbers? I cannot think of anything.
Find gamma.
Do you remember those things? Do you remember the summations for any of them?
It was, I think 1 plus 1 over a divided by 1 plus 1 over 1 divided by 1 over 1 plus 1 divided by 1 over 1 plus.
Oh.
And if you did it recursively, you just found an error value.
Eventually.
Yeah, that got less than. If you did it with a for loop, you just say loop 60 times. And
Yeah. Yeah. You need you didn't break it with 60, right? With recursion. You need a huge thing to break the stack.
Yeah, no, I think I did up to over 1,000 when I did.
Okay. Oh, but I can't do this, right? I need to pass double. So you're doing 1 divided by 1 plus 1, or 1 divided by 1 plus 1 divided over 1 plus 1? That stuff? Never mind. Never mind. I'm not doing that.
Yeah.
I have no clue what I'm doing. So I won't do stuff when I don't know what I'm doing. How about printing stuff? Woohoo! So much fun. Yeah, we have time. Actually, before that, let me explain the other 2 pieces that we are missing, and then let's focus on read and sum. And it actually involves negative numbers. Read numbers until you read -1 rather than 0, right? And now return their sum. So what can we do? What do we need to change there?
The condition.
The condition, right? Is that good?
For the prompt too.
Okay. You're nice to the user. We don't care about user experience here. No. That's good. Thanks for catching the typo. I wouldn't have changed that one. But what would this work?
No, you can say if too.
What happens when the user enters that -1?
Yeah. It's part of the sum.
I'm adding it to the sum, right? So what do I need to do? How can I make it so that I don't add it to the sum?
Oh, yeah.
What would I do?
Do a condition.
Do an if statement, right? And then, so if input different than -1, right? Is this cool? It works. Is it ugly? Absolutely, right? Especially when you start having more things inside the loop, right? The designers of C invented one more thing, and then everybody copied it, which is the idea of a break statement. A break statement gets you out of the loop and after the loop. Does that make sense? So in this case, we would do, instead of doing it this way, we can do if input equals -1, break. And that gets me out of the loop. Does that make sense? Now, is my condition important? Not anymore, right? Because what's going to get me out is that break statement, right? So, I can change this to what? What's something that always evaluates the true?
1. Or true.
1, yeah. True! True is always true. Does this make sense?
Yes.
This would work. In fact, we're gonna try it. Cool. I didn't print it, of course.
Yeah, because that's return instead of else print line.
Oh, that's cool. That guy should do. This guy who didn't print. That guy should return. Woohoo! And we got the right sum, right? Now, most people wouldn't write it like this, right? It feels more natural to do it the other way around. Just because it has less letters. most people would write it like this. That's how I like to write it, right? Many times things that deal with input end up with this kind of pattern. I just read, and if the input tells you to stop or something like that, just break out of the loop. Another way to write it would be with a for loop. It is weird, but in a for loop, you don't need the initialization, you don't need the increment. Actually, you don't need anything. This is ugly as hell, in my opinion, but it works. Many programmers like to use puns, and they read this as forever. It works. It compiles. It works. I would much rather write while true, but we can modify this so that we only print, we only add up even numbers by adding one more thing. So we can do if input is odd, right? So let me just do %2 = 1. Continue. And what continue does is gets you to the checking condition again. Actually, to the increment if you were doing a for loop.
So basically that skips everything below it. Goes back
Keeps
to the start.
everything below and gets to the end of the brace.
But it doesn't exit.
Doesn't necessarily exit. So you go check the condition and maybe you continue, maybe you exit, maybe whatever was going to happen. Does that make sense? I almost never use continue. Mainly because I use for loops and I can never remember whether the increment gets done or not. I think it gets done, but I don't remember. And so normally when I start doing that, I said, why the heck am I doing this? And use if statements or something like that. And I seldom use continue, just you should know that it exists and sort of kind of what it does. Or at least so you can go Google it later. Never mind, we never talked about it, we never did it. Continue just skips till the end of the body of the loop. I never use it. I do use break a lot. If you have noticed, in particular, if you ever took a programming, an intro to programming class, you would have noticed that I have horrible manners for programming. Now, many intro programming classes teach you stuff like you always have only one return, so you do temporary variables to not return twice, right? And those kinds of things. Many intro programming classes will tell you not to use break because it's evil. I tend to like evil stuff. Now, I tend to think that this actually makes perfect sense and makes the code more clear. And you guys are adults. Or something close to that. So you can do the hard stuff. I don't see this as terribly hard. The only thing that I would do differently is do a while true. Ooh, now you'll see why you do recursion. You remember that we had a nicer power function? that did it by halves, right? Probably have it here. No, I have no clue where to put it. Let's remake it just for fun. What did we do here, right? We still have the same base case. If exponent is 0, return 1. Otherwise, right, if is even, so let me do is even. If my exponent was even, or actually either way, let's do this. Int half pow equals how log of base exponent divided by 2. And so if this is even, return half pow times half pow. Otherwise, right? We did this one recursively, right? Yeah. I think we did the first time we did recursion. If not, let's do it now. And we can see how it works, right? What's going to happen if I call it with a base of 1, just so I don't get stuff, or maybe a base of 2 and an exponent of 16? What's going to happen? I'm going to call 8, right? With an exponent of 8, then an exponent of 4, then 2, then 1, and assemble the whole thing, right? Does that make sense? So I can do system.out print line. Two to the 9th power. Oops. Ah. Public static. Ah. Doesn't even really need to be public. It does need to be static. No. No. And to specify who is even. This other power. So I called it with 2 to the 9th power, right? So it printed, it got called with 9, 4, 2, 1, and eventually 0, right? Oh. What? Did I print powlog? Yes, and so I returned 1, which is wrong. Something is wrong. I think not do this one. Oh. Ew. No. What's my base? No, I did 2. What am I doing wrong? What are we doing wrong? Okay, not you, only me. Okay, we can try it. Just first power, right? We get 1 rather than 2. Why? Because
Is it condition?
is even should be exponent, not base. And so I am an idiot. Okay. So we're going to the 9 power. What do we expect to get back? What's 2 to the 9 power? Let me cry. You should be able to calculate it. Let's see you guys calculate it. 2, 4, 8, 16.
512?
Yes. 32, right? 64. You should sort of kind of by now memorize 8. 2 to the 8 is 256. Why is that important? There is 8 bits in a byte, right? The byte is kind of the smallest unit that we use in computers. And so in the smallest unit of data, you can fit 256 values, right? The other one that you should memorize is 2 to the 10, which is what? 1024. Why is that important? Because it's very close to what other number? What number looks really nice and round to us? 1000, right? So 2 to the 10 is 10 to the 3. So in 30 bits, you can fit about 9 bits. Does that make sense? And also because you know that they're cheating on you when they sell you stuff. Actually, it's not true. It's our fault. Kilo was always 1000. And then we reused it for 1024 instead of 1000. And so they used to sell you stuff on kilobytes that were 1024 and megabytes that were 1,050,000 and peanuts bytes until they discovered, oh, if we call it 1,000,000, then we give you a few more megabytes and gigabytes and those kinds of things. So now they use million instead of 1,050,000, and so they can save 5%. So you guys should know kind of by heart, 2 to the 8 is 256, 2 to the 10 is what 1024, right? And it's probably a very good idea for you to, when you're bored and about to fall asleep, just do powers of 2 or something like that until you memorize a bunch of them. 2 to the 16 is 65,000 and peanuts. And 2 to the 32 is 2 billion. Maybe 4 billion. And peanuts. 2 billion, right? Nice. No, it's 4 billion impedance. 2 to the 31 is 2 billion, and 2 to the 32 is 4 billion. And then 2 to the 64 is an obscene number. But so this should return 512. Cool. Now, we do it recursively. Can we do it with a loop? Let me eliminate this stuff. Could we do this with a loop? We can, but it's going to be slightly painful. Right? So we are going to do while exponent different than 0. God, how can we do this with a loop? It is actually painful. It is actually very, very painful to do with a loop because we don't know which ones do we need to add. So this is why recursion is sometimes nicer than loop. This is one example where a recursive function is doable. A loopy function would be a pain in the neck. But we're talking about loops, so let's do stuff with loops. Games. Or, yeah. You have not seen this. This is a secret number. Let's do it with a do while. How about that? We are gonna be telling the user to go high or low, right? Whether they went high or low. They're trying to guess this number, right? So we can say out the print line even better if I do it right here. Oh, I can't. If so we're going to do this while input is not target. If input is greater than target, we do too high. too low. You got it. Could do Guess my number. 4, too low. 8, too low. 12, too high. 10. Yay! We are really good at guessing numbers. We can actually do. We can ask. Most programming languages have random number generators. Oh. Which is Java util random? Util random. So we can do Java util random. Does it have? I can pass it this, so this will get me a number between 0 and 100. Actually, between 0 and 99 probably. Oh. I need to create a new random. It's not static. So if we're trying to guess a number between 0 and 100 or so, what do we guess? 50. Too low. Too high. 2. 69 or so, right? The average of, so it's between 62 and 69, so something like 66. Too low, 68. Too high, 67. And if we run it again, we should get something different. That should be 87, right? Yeah. Yay! And I didn't follow the optimal strategy. I don't think we actually did any standard counting, right? How do we count from to and print the numbers to print string, to the print string? The easiest way, and you will probably start seeing this a lot, from I less than or equal to 2 plus I. Not system, just auto println. 1 to 10. Send that out. Yeah. No static, so. Woohoo! Yay! We tend to do those kinds of things with for loops, right? You will probably see for loops like this. What's the default variable for a for loop? I. Why? Because that's what mathematicians use for series, right? What's the next one? If you need a nested for loop, J, right? And the next one? K. What's the default name for a function? Foo. Don't ask me why.
Really?
And the next one is bar, and the next one is bash. Don't ask me why, but that's.
Because reasons.
Sorry?
Is that because reasons?
Because reasons. Yes. Yes, the first, every programmer that defines functions defines the first function is foo. Then the next function you define is bar. And then if you ever need 3, you do bash. But actually this is a nice thing about for loops, or loops in general. We can nest them, right? And then we get so void print multiplication table, and how can we print? Have you seen the multiplication tables? Right? With stuff here and here, right? So, what do we do that? For int, let's use call for column, right? 1, we're going to start at 1. And let's gonna just do it until 6.
Would it matter if you put the plus plus in front of call?
Does it matter? Who remembers? It doesn't matter in 99% of the cases. If it matters, you're doing it wrong. But, right? Prefix first adds and then returns the new value. So plus plus call, right? Returns the new value. Postfix call plus plus returns the old value. In here, it doesn't matter because you're discarding that value. You're just calling it to change the variable. You should never use that value, so it doesn't terribly matter. Chances are the compiler will compile it away either way, but officially, prefix is faster because you don't have to keep the copy of the old value around. So if the compiler wasn't smart, prefix would be faster. Chances are the compiler is smart and it's just about as useful as knowing how many angels can fit on the head of a pin. But real programmers use prefix always because it's faster. Doesn't terribly matter. I always use prefix because I learned it in C, and at the time it was probably faster. Actually, what I want to do here is out the print.
Here.
sorry?
PS.print.
Yes, sorry. And what do I want to print here? PS.print. Oh, wait, it has to be the other way around. The outside go the rows, right? And inside the columns. I'm gonna print the value of row. Row times col. Hopefully this will work. This brings a new line. So this will almost print. I need my top header, right? Which is actually this. I need to go to my columns and print col plus /t. Yay! What does the /t do? It prints a tab character, which by default is 8 characters, so it makes them more or less line up. Is this cool or what? Now you're doing this loop and this nested loop. That's what makes it go all the way in here, right? Isn't this cool? I will see you guys on Wednesday. Reminder, on Wednesday we will go over the recursion assignment. So if you haven't submitted, make sure that you submit before Wednesday, because I will not take any submissions after Wednesday. We are going to go over the solution, then we may do some more loops or go for the assignment. The assignment 5 is basically the same as assignment 4, but now do it with loops instead of with recursion. And 10 days from today, we will have our midterm. If you are in the face-to-face section of the class, if you're online, then you can come to this one, or Sunday, or whatever. Actually, if any of you actually think that you would rather come on Sunday, you are free to ask and do so, rather than on Wednesday.
Isn't this coming Sunday?
It's not this coming Sunday, the other coming Sunday. October 2nd. I get all confused about English. It's next Sunday. This, yeah. Yeah, those things are they're not specified, right?
Yeah.
Sunday, October the 2nd, or whatever the email said. I think it's Sunday, October the 2nd. Not 6 days from today, 13 days from today.
What time?
At 2 p.m.
Just wanted to make sure it wasn't like 8 a.m. right?
Nah. I just choose something horrible for just, it's horrible for the online people, but on the other hand, seldom do people have stuff scheduled for Sunday at 2 p.m. That's why I usually end up with that